So let's get right into it. There's this massive question floating around in the world of AI right now. Can an AI really learn the fundamental laws of physics? Just by watching things happen.
I mean, you've seen it, right? These incredible videos that pop out of models like Sora. You just type a few words and poof, you get a scene that looks so real it honestly feels like magic. You'd swear they have this deep, intuitive grasp of how our world works.
But that leads to the multi-trillion-dollar question. When an AI generates a video of, say, a ball falling, is it actually applying the law of gravity? Or is it just a super sophisticated parrot, perfectly mimicking patterns it's seen thousands of times? Is it seeing, or is it truly understanding?
To even begin to answer that, researchers had to get really clever. They needed to set up an experiment, a controlled environment, where they could actually put the AI's knowledge to the test.
Because, the real world is it's messy. A video of a cat jumping has a million different things going on. The lighting, the fur, the camera angle. You can't isolate the physics. So they did the next best thing. They built their own world from the ground up. A simplified toy world that's basically a perfect little physics lab for an AI.
And here it is. This is that toy world. No complicated backgrounds, no confusing textures, nothing like that. Just simple shapes moving around in a 2D space. In this world, every single thing, the object's position, its speed, its mass, it's all perfectly known and measurable. It's the ultimate clean room to see what the AI has actually learned.
Okay, so the lab is all set up. Now it's time to give the AI its final exams. The researchers came up with 3 very specific kinds of tests, each designed to poke and prod at the limits of what the AI really knows.
First up is what you can think of as the review test. The official name is in distribution. Basically, they ask the AI to predict what happens in scenarios that are super similar to its training data. This is just to check, does it remember what it was taught?
Then, things get a lot harder. This is the extrapolation test, or out of distribution. Here, the AI has to predict stuff it has never seen before. Like, what if a ball is moving twice as fast as any ball in its training? Or if it's 3 times bigger? This isn't about memory anymore. This is a test of whether it can generalize a real principle. And finally, we have the remix test. Let's say the AI has seen red balls, and it's seen blue bars, but it's never seen them together. What happens when it has to predict their interaction? This tests if the AI can creatively combine the concepts it already knows.
So the AI goes through this whole gauntlet of tests. So what's the verdict? Well, the results were pretty fascinating, actually. And they tell a really powerful story about what's going on under the hood of these models.
And the results really couldn't be clearer. For the review test, the stuff it had already seen, the AI passed with flying colors, aced it. But for the extrapolation test, the new situations, a massive, undeniable fail.
And this chart, wow, this really puts the scale of that failure into perspective. Just look at the error rate. For the familiar stuff, the error is practically nothing, just 0.012. But for the new stuff, it skyrockets to 0.427. That's not a small mistake. That's a total breakdown.
Now here's the kicker. The usual solution in AI is just go bigger, more data, bigger model. But the researchers found that doing that had almost 0 positive effect on this problem. Sometimes it even made it worse. Just throwing more data at it didn't teach it physics it hadn't already seen.
But just when you think you got it all figured out, there's a plot twist. Remember that third remix test? Well, for that specific challenge, scaling up the model and the data worked absolute wonders. A completely different story.
And the data here is just so stark. This table shows what they called the abnormal rate, which is basically how often the AI just made up something physically impossible. So look, when it was only trained on 6 different combinations, a whopping 67% of its predictions were just plain wrong. But when they scaled up the variety of its training to 60 combinations, the error rate just plummeted down to 10%. It got so much better at handling new remixes.
Okay, so this is weird, right? Why does scaling work for one test, but completely fall on its face for another? To figure that out, the researchers had to try and peek inside the AI's mind and see how it was making decisions. And this is the core insight they found. The AI isn't acting like a physicist with formulas and abstract rules. No, it's using something called case-based reasoning. The best way to think about it is like a master librarian. When you give it a new problem, it doesn't solve it from scratch. It just flips through its entire memory, finds the most similar-looking case it's seen before, and then just copies the outcome.
Right. So that leads to the next puzzle. If there isn't a perfect one-to-one match in its memory,
How does it decide which old example is the closest? What does it care about the most? And check out this experiment. It's brilliant. They trained the model on only two things, red balls and blue squares. Then they gave it a curveball, a red square, a mix it had never seen. So what would it do? Would it prioritize the color red or the shape, square? And as you can see, the AI instantly morphed the red square into a red ball. It decided matching the color was way more important than matching the shape.
So after a whole bunch of these clever little tests, they actually uncovered the AI's hidden rule book. It has this strict and kind of bizarre order of operations. Number one priority is color, then comes size, then velocity, and all the way down at the bottom of the list is shape, which, by the way, might explain why so many of these AI video models seem to struggle with keeping the shape of an object consistent.
Okay, let's pull all these threads together. What does this all mean for teaching an AI physics? And what's the real scaling law we should be paying attention to?
Well, it turns out the real scaling law isn't what we thought. Naive scaling, just dumping terabytes of more video at the problem, that's not going to be enough to get an AI to discover physical laws on its own. The key isn't volume, it's variety. Just like that remix test proved, giving the AI a much wider, more diverse range of combinations is what allows it to generalize, at least within the boundaries of what it's seen.
And that really leaves us with the big, final question hanging in the air. We've pretty much confirmed that for today's AI, seeing is not the same as understanding. So the grand challenge ahead of us isn't just building better mimics, it's figuring out how we build an AI that can finally move beyond just matching patterns and can actually truly learn the fundamental rules that govern our world.